Hey, eighth graders, this is Digits Lesson 4-1 about scientific notation. And this is the launch. Now, the launch we usually do together in class, but I'm going to show you part of this launch and ask you to complete the rest of it today as part of your lesson. Here are the directions.
Order the tiles from least to greatest numeric value. Explain how you know your order is correct.
Okay, so least to greatest. You guys are smart. You know that means start with the smallest and go to the largest. And you notice they show you two different things. They show you numbers times 10 to different exponent powers, and then regular numbers like we're used to. So try to think of those separately. So I'm going to start you off this way. I'm going to let you know that 30 and 3 times 10 to the first is the same thing. So 30 equals 3 times 10 to the first. And that is your smallest number out of all these choices. But these mean the same thing. I'm also going to show you the largest number. Now we can clearly see if I had to choose 3,000, 30,000, or 300, what's the greatest number? Obviously, we would say 30,000. So I will also let you know that 30,000 and 3 times 10 to the fourth means the same thing. So now you know your least number, 30, which is equivalent or equal to 3 times 10 to the first. 30,000 is your greatest, which is the same or equivalent to 3 times 10 to the fourth. So also notice that 3 times 10 to the first is 3 times 10 with 1 0. So exponent matches the number zeros. 30,000, 3 times 10 to the fourth, you notice 3, 1, 2, 3, 4 zeros. So matches the exponent. So think of that when you log on to Digits today and you try to complete this launch. And you notice that there's also a solution button. So when you're done, when you arrange it, you can click solution and see if you're correct. Okay, so I'm also going to show you part 1 today and ask you to complete that. So part 1. Okay, so here we go. So a little bit of a video for you to see.
You can express numbers as products using powers of 10. The number 5 can be expressed as 5 times 10 to the 0 power. The number 50 can be expressed as 5 times 10 to the first power. The number 5/10 can be expressed as 5 times 10 to the negative first power. The number 5 can be expressed as 5 times 10 to the second power. The number 500 can be expressed as 5 times 10 to the negative second power. The number 5,000 can be expressed as 5 times 10 to the third power. The number 5,000 can be expressed as 5 times 10 to the negative third power.
Okay, so you see a couple different things here. You see positive exponents and you see negative exponents. There's also a 0 exponent in here. But let's look at those positive exponents first. And we're going to work our way up. So 50 is equal to 5 times 10 to the first. And they tell you that the exponent is 1. Your exponent is 1. And notice that the exponent is 1, there's 1 0. So 5 times 10 to the first power is equal to 50. 500 is equal to 5 times 10 to the second power. They tell you the exponent is 2, which is correct. But you'll notice the exponent is 2. There are 2 zeros. So 500 is equal to 5 times 10 to the second power. 5,000 is equal to 5 times 10 to the third power. The exponent is 3. You notice exponent is 3. There are 3 zeros. So 5,000 is equal to 5 times 10 to the third power. Now let's skip down to these negative exponents. And I want you to notice that a negative exponent does not mean that the answer is negative. So these answers are not negative. 5 times 10 to the negative first power, the exponent is negative 1, is 0.5. 0.05, which is pronounced 500ths, is 5 times 10 to the negative second power. Your exponent is negative 2. But notice your answer is still positive. 0.005, which is 5 thousandths, that's how it's pronounced, is 5 times 10 to the negative third power. That's a negative 3 exponent. Negative 3 exponent. But so I want you to notice this. 0.5, there's one decimal place. Your answer is negative 1, or your exponent's negative 1. 0.05, 2 decimal places. Your exponent is negative 2. 0.005, negative 3 exponent. Notice there's 3 decimal places taken. So a negative exponent does not necessarily mean a negative answer. And here you can see there is no negative answers here. So hopefully that's clear. Let's look at the next page, which asks you these questions, whether they're true or false. So looking for patterns in the table, decide whether each statement is true or false. As the exponent of 10 increases, the numbers become greater. So as the exponents increase, exponent of 1, exponent of 2, exponent of 3, does the answer increase? Okay, hopefully you'll see that. A negative exponent of 10 makes the number negative. So we just covered that on the last page. Does the negative exponent make the answers negative? So let's decide whether that's true or false. 5 times 10 to the third is greater than 5 times 10 to the second. So if I go 5 times 10 to the third, which is 5,000, is that greater than 5 times 10 to the second, which is 500? 5 times 10 to the negative 3 is greater than 5 times 10 to the negative 2. 5 times 10 to the negative 3, is that greater than 5 times 10 to the negative second? So hopefully you had time to look and think of those answers. I know I went kind of quickly, but let's look back at those again. As the exponent of 10 increases or gets bigger, the number becomes greater. So as the exponent increases, does the number become greater? Hopefully you would say yes, that's true, because it is true. 50, then we go to 500, which is greater than 5,000, which is even greater than that. A negative exponent of 10 makes the number negative. So here's our negative exponents. Here's our answers. Are those answers negative? No, they are not. So we would have to say that is false. 5 times 10 to the third is greater than 5 times 10 to the second. So 5 times 10 to the third, that's 5,000. Is that greater than 5 times 10 to the second, 500? True. 5,000 is greater than 500. And answer or question D, 5 times 10 to the negative third is greater than 5 times 10 to the negative second. So 5 times 10 to the negative third, 0.005. Is that greater than 5 times 10 to the negative second, which is 0.05? No, that's false. Okay, because the farther away you are from the decimal point to the right, the less your number is worth. So this is less than this. Okay, so that would be false. Any questions on that? Let me know. And then the third, order the following numbers from least to greatest. 2.3 times 10 to the second. 2.34 times 10 to the second. 2.34 times 10 to the negative second. 2.34. So your answer choices. I'd like you to try this and see if you can get that answer. When you log on today, it will allow you to click correct answer. If you're not sure, you can click solution. So that is your task for today, to go back over part 1, the launch and part 1. See how you do. Any questions, let me know. But I think you guys will handle that well.